All right, guys, so I'm going to talk about section 8.4 today, which is titled Rational Expressions. Learning target is short, sweet, to the point. I can simplify, multiply, and divide rational expressions. As a side note, we focus a lot on restrictions to the variable as well, which has to do with the denominator being 0. We'll skip some today just for time purposes. But if you want to see any of those tomorrow worked out, you can. They'll also be on the filled out notes as usual. So other than that, I would say we've kind of done this example 1 stuff before. So I'm going to kind of just get right to it then. Example 1 wants us to simplify the following rational expressions and state any restrictions to the variable. Okay. So the key, really the only key that I would focus on from this, well, a couple things. This is really the biggest key right there, right? You being able to factor, and then from there it's pretty easy to do step 2, step 3, and then the next part where you kind of have to think is on those restrictions. Okay. So with that said, let's go ahead and look at 1A. All right, so got to be able to factor first because we can't just see those common factors. We gotta have simple linear factors. Then we can tell. All right, so factoring out the top, that's going to give me, I'm thinking what multiplies to 2 adds to 3. So that'd be 2 and 1. So x plus 2 times x plus 1. All right, and then now it's clear to see that we do have a common factor of x plus 2. So kind of cancel those 2 out. And what we're left with is x plus 1 over 1, which we would just say is x plus 1. Which if you just look at x plus 1, that doesn't, its domain would be all real numbers, right? But we have to look back at our original expression and the denominator specifically of the original expression, use the 0 product property to come up with, I couldn't use -2, okay? So my restriction is x can't be -2. So it's kind of interesting to think about, if you think about this graphically, which I'm not going to take the time to punch it in, it's kind of interesting to think that like this complicated looking expression right there, if I graph that, y equals that, is equivalent to y equals x plus 1, which we know is just a line with a slope of 1 and a y-intercept of 1. How it really, how those would be the exact same expression. So that's kind of weird, but a lot of times we end up with stuff like that. All right, so looking at B, that's a lot simpler, right? If we're following our checklist, we would factor out the bottom to x times x. Cancel out your common factors, and we'd be left with just 1 over x. Is there any restriction to the denominator here? 0, that's right, very good. X can't be 0. Now, that'd be one approach, how I just showed it there, or you might have thought exponent rules, right? So you might have thought 1 minus 2 gives me x to the -1, which is equivalent to 1 over x. Either way, works just fine. Any questions so far? All right, let's keep rolling then. So I am going to kind of skip one. Well, actually, let's look at C. C is a little bit confusing because it doesn't originally look like there was a common factor. But remember a rule, like if we're going to look at a linear expression, like the denominator, 3 minus x. That's not really in simplest form. Simplest form is when your lead coefficient is positive, right? Usually we write the x part first. So let's see what it looks like when we rewrite it that way. Top's already, or the numerator's already factored, so can't do anything with that. But if I factor out a -1, or just looks like a minus sign, and write the x first, watch what I end up with on the bottom. So that would give me a positive x and then a -3, right? So it was kind of hidden in there, but once we manipulated that a little bit, we can see that there's a common factor of x minus 3. And what we're left with is positive 3 over -1, which is just -3. All right, and then we look back here, or you could say here, either way, for our restriction, which is that this is going to be true for any x value except for 3. So x can't be 3. All right. So again, that's just kind of interesting to think about, like if I type that into Desmos or my graphing calculator, how it would just end up being y equals -3, which is just a horizontal line, right? So yeah. I just factored out a -1, so I just wanted my x term to be positive, so I just factored out a -1, and all that does is flip the signs on both terms. Well, if you didn't do it, you probably wouldn't know that you needed to reduce, so you would just say it can't be reduced, which would be incorrect. So that's why we wanted to do that. Does that make sense? All right. Let's just skip example D for time and space purposes. We may come back to that tomorrow. That's a good one to do. Also, I'm going to skip E just because I think it's a little bit simpler. And I'm going to have you guys do as much as you can. Give you a couple minutes to get ahead of me on example F. All right. So go to example F. You know you're going to need to factor the top, factor the bottom. That may be all you can do in 2 minutes, or maybe you just do part of that, or maybe you finish the whole thing. Feel free to work with people around you. I won't call on you on this. I just want you to get ahead of me. Just see. That'll give you a good idea if you have any questions or not. And it may just be the case that you're a little rusty on factoring if you're having trouble, but you know we've worked on that a bunch this year, so hopefully it's just like riding the bike. Miller, were you watching Huddle or something? What are we gonna do with you, boy? That's all right. I forgive you. All right. Does anybody want to volunteer just what the top factors out to? How can I factor out the numerator, Shrieker? X plus 4x minus 2, that's correct. Anybody got the denominator done for me? Madison? Okay, and I actually made that same mistake, but that, I don't know why I saw the same thing as you, but that is actually incorrect. But so if we did -6 plus 1, that would give us -5, but it multiplies to -6. So I don't know what it is about that problem that made me think the same thing as you there, but I made that same mistake. It's not that. Does anybody know what it is? Clayton? It's -3 and -2. Okay, so I don't know what it is. It's like we both made the same error there, but yeah, -3, -2. So again, this is just like it'll be like riding a bike, right? We factored a bunch. You'll get better as we go. All right. So if we did end up with like what Madison said, and I made the same mistake, like Ian, I was talking to you. That's one of the mistakes that is on your notes. That would be like we would have no common factors there, and we would say it just can't reduce. But when we factor it out correctly, we see that there is a common factor, x minus 2 over x minus 2, and then that gives me just x plus 4 over x minus 3. And then we say x can't be. Here's a common mistake. A lot of people just say x can't be 3 and then they're done, right? Because they're just looking at their simplified answer. But remember, we have to include all of it, right? So it's +3 and also +2. Yes. Good. That's what somebody asked in first period too. So let's talk about that. All right, so the question was there, like on this final answer, like basically why don't the x's cancel out? In other words, like, you see x over x, you would think why doesn't that cancel? And visually, kind of it looks like it should. But I would say if it looks like it should to you, then maybe as a reminder that like x plus 4 is one factor that just stays together, you might want to put it in parentheses. So that might make it more obvious that the x plus 4 is one term, the x minus 3 is one term. So what you would be thinking of, like when would the x's cancel? That would be more like this. Okay, that would be more like if we had 4x over 3x, then they would cancel and we just have 4 over 3, right? So that's the difference in multiplication versus addition. Does that make sense? Okay, so good ask there. Anybody got any other questions before we move on? All right, let's do one of those two at the bottom, and then we'll go to the back side. Anybody got a preference? G or H? Anybody want to call it? If not, I'll just pick one. All right, I'll just pick one then. Let's just do G. All right, so looking at G, up top, what we want to do is, again, we want a positive x term, right? That'd be my lead term. So I need to factor out a negative whatever. Okay, in this case, we can factor out a -4. So that's going to leave me with positive x and a -3. If you don't do that, you won't see that there is a common factor later. Okay. The bottom one is called that's one of those special cases. Anybody remember what that's called? If you have a perfect square minus a perfect square, yeah? Difference of squares, right? And those always factor out. That's one of our shortcut things. You just remember a plus b times a minus b, right? So x plus 3 times x minus 3 in this case. So now we see x minus 3 cancels with x minus 3. What we're left with is -4 over x plus 3. And you can put that x plus 3 in parentheses if you want, or you could skip it. Okay. For our restrictions, we look at both of those. So we'd say x cannot be -3, +3. So we could use the plus or minus symbol there if we wanted to. So does anybody have any questions on that one? All right, I meant to do one more thing, but I skipped it. So let me backpedal before we go to the next examples. So on our example before this one that we did, I wanted to make a point about how you could, in theory, like check your answers. It's not totally straightforward, but if you did want to check your answers to see, did I reduce right? Are these fractions really equal? You could use your graphing calculator. So like what I did while you guys were trying to factor is I typed this in. So I typed in my original expressions. And notice I do need to use parentheses or the calculator will read it wrong. All right. And then what I could do after I'm done is type in my reduced fraction, right? So as y2. So that'd be x plus 4 over x minus 3. And then how this is helpful then is a couple reasons. So if I look at a table now, that second graph, the first thing I look for is, do we have equivalent output values? And you can see very quickly that we do, right? So you can see that the y1 and the y2 columns match up. That tells me that basically I reduced correctly. I can also see if my restrictions are all included, right? So we said x can't be 3 or 2. So if I go down the line, 2 is an error, right, on our original fraction, and then 3 is an error on both, right? So that shows me that my restrictions are correct as well, all right? So you can get a lot from your calculator on this, but that's doing a little bit extra. You don't really have to do that. That's just checking your answer, okay? I wanted to make that point. Anything before we go on? All right, so the rest will be on your filled out notes. We can also look at those tomorrow. So if you guys flip over to the back side. We're going to talk about multiplying fractions or multiplying rational expressions. All right, so just the fundamental kind of reminder here is that when we multiply fractions, we just multiply straight across. After that, we just try to reduce. Or actually, before we multiply, we try to reduce like you would cross cancel, you know, if you were multiplying, you know, 3 over 4 times, you know, 7 over 12 or something. You would try to cross cancel. All right, so let's just do 1 or 2 and see what you guys have. All right, so we know we're going to multiply straight across. So I'm going to go ahead and write these in factored form. All right, so 2x minus 8 factored would be 2 times x minus 4. Next, I'm going to factor this part. So what multiplies to 4 adds to 5? That'd be plus 4 and plus 1. So x plus 4 times x plus 1. All right, and then that's going to be over. Now I'm looking at this difference of squares. That's going to be x plus 4 times x minus 4. Multiplied by whatever our last part factors out to. So that's going to be 4 plus 4. So x plus 4 times x plus 4. You could write x plus 4 squared, but if you're reducing, you probably want to write them out as 2 separate factors just in case. All right, so now we have it in factored form, and you're not going to want to just multiply all that out because you'd just be multiplying all day, right? So what you want to do is try to reduce from here. So just looking factor by factor, there's nothing on the bottom that matches up with 2, right? So we keep going. Looking for x minus 4, there is a match for that, so I'm going to cancel that and that. x plus 4 has multiple things you could match it with. Now here is one thing that first period had a question on, like why don't you cancel them all out? It's got to be a 1-to-1 match. In other words, we'd have to have 3 x plus 4s up top to cancel all 3 down bottom. All right, so at this point then, we don't have anything that matches with the x plus 1, so we're done reducing. So then what we're left with is 2 times x plus 1 over x plus 4 times x plus 4. Just to save some writing, I'm just going to write over x. I meant to write x plus 4 squared. Try that again. X plus 4 squared. All right, now I'm not sure if MathXL would accept that. I probably would if it were a test. If not, though, they're just wanting you to multiply through up top, right? So if that's not acceptable, then they would be looking for 2x plus 2 over x plus 4 squared. All right, restrictions. Remember, where we want to look is right here, okay? The restriction for this part would be -4, +4, -4, and -4. You don't have to write -4 3 times, right? So overall, it's just positive and -4. Okay, so I boxed in this answer, but you know, that may be acceptable on MathXL. I'm not sure. I forget. All right, so let's, if anybody has any trouble with like these, we can look at those tomorrow, like B. Okay, I don't really imagine that you will. I would just say look to cross cancel there. Okay, and those are pretty quick, but I'm happy to show them tomorrow. So I'm gonna have you guys just get as far as we'll do this like we did the last thing. Just get as far as you can on C in the next 3 minutes, and then feel free to ask me questions or people around you, and then we'll kind of touch base on it at the end. And this will be in the video, so you guys don't need to look up now, but I'm going to show you how you would type in this original, if you wanted to type it into your graphing calculator, how you would type in the original expression. Guys, I've been a little down in the dumps with my Braves getting off to an 0-4 start. They played a doubleheader yesterday, got their first 2 wins of the season. So I'm feeling a little bit better about that part of my life. I'm like, we can't have the same sports year where my Cats go 9-16, and my Braves are going to be bad too. It's like, what's happening? I think my Braves are going to get it going. You know who's been hitting them out of the park? The Kung Fu Panda, baby. You probably don't even remember who that is, do you? Pablo Sandoval. He was good like years ago for the Giants. He's my age, so he's an old dude. But great nickname, Kung Fu Panda. And he's still smacking them out. All right, we're getting a little bit up against it on time, so instead of calling on people, because there'd be a lot to call on for there, I'm going to go ahead and just start to work through this. So you can keep working or check your factoring if you're that far. All right, so I went ahead and just wrote it all out in factored form. I'm going to leave that there for just a second and see if let you just double check your work or get caught up with me. So if anybody has any questions, obviously let me know. You know, and I would say too, you know, the restrictions are going to be, you know, included in the answer. It may be a good idea just when you're here, just to go ahead and do that semicolon, and I'm going to go ahead and write out my restrictions first. That may be a thing you try. So we'd have -3, -1, +5. All right, and now I'll go ahead and try to make any cancellations that I can. So looking at x plus 3's got a match down here, so I can cancel those. X plus 2 does not. X plus 5 does not. X minus 5 does. So what we're left with is x plus 2 times x plus 5 over x plus 1. And like I said, MathXL may take that. If they don't, though, you just have to multiply that out. So if you multiply it up top, you get x squared plus 2x plus 5x, or plus 7x plus 10. All right, and then you got your restrictions over there as well. Make sure we say the word or there. All right, so both are equivalent and both are reduced. Does anybody have any questions on that? Now, I did go through in the video, like we talked about using our graphing calculator to kind of help double check our answers. I went through and just showed you how kind of tedious it would be to type this in. There's like double parentheses and all kinds of stuff. So if you're interested in watching that, you can. I do want to do, I see you guys wanting to quit on me because it looks like we've done a lot, but I do want to show you one division problem, okay? I want to show you one division problem and make one big point about it, because basically if you understand multiplication, you understand division, okay? So again, the key fundamental reminder: to divide by a fraction means to multiply by its reciprocal, right? That's all we're doing. Divided by a half is the same thing as times 2, right? So that's what we do. Here's the only thing that's different. The only thing that's different is the restrictions, okay? So restrictions on this come from 3 places, all right? So restrictions, that's where we say x can't be equal to da-da-da-da-da. Restrictions come from here. You might have guessed that. Restrictions come from here. You might have guessed that. But where most people wouldn't think is they also come from here. So 3 out of the 4 expressions, you know, we need to look at what their zeros are, okay? And the reason for that is because even though this is in the numerator, it comes after a fraction bar right there, right? So technically it's kind of under a fraction bar. So you may want to note that somehow. All right, so step 1, kind of the key first step, is to write it as a multiplication problem. and then you just kind of take it from there, right? So this is equivalent to x squared plus 5x plus 4 over x squared plus x minus 12 times, and then flip it, right? So times 2x squared minus 6x over x squared minus 1. All right, so at this point, what I'm going to do is I'm going to continue to work this problem. I'm going to factor, I'm going to reduce, but I'm not going to talk, so that if you feel comfortable enough, you can work it on your own and then check at the end. If not, though, just stay with me, okay? All right, so those of you who are kind of working on your own, let me ask you just to maybe watch for just a second, because it is just a little bit confusing to look for those restrictions. Okay, so so kind of here is my thought process. This is the easiest way I know how to explain this. You might come up with a better system, but remember, 3 out of the 4 original expressions we're looking for the zeros on, right? So so like this one. That matches up with this, right? So from that, we'd say x can't be -4 or +3. Okay, we also said this one would be included, which is that. So x can't be plus or minus 1. And then the last one we said would be included in the restrictions would be this, which we know most people would say x can't be 3, and then they'd be done with it. What do people forget on that one? Anybody remember, or anybody see it? What would be my other 0 for this expression right here? 3 and what else? Not -2, but you're looking at the right thing. 0, right? Remember, this is a linear factor too, right? So x can't be 0. Since we've already written x can't be 3, I'm not going to write it again. So look at all those restrictions, right? You end up with a bunch. All right, so I'll shoot out the filled out notes in the video by the end of the day. I will go ahead and post your assignment, but I'm going to let you work in class tomorrow. So, you know, if you want to try to work ahead, that'd be great. If not, just know you'll have some time tomorrow.